All right, folks. Today we're going to look at vectors, both in 1D, which we've already done, and 2 dimensions, which we've talked a little bit about but haven't done much with. Okay, so before we get started on that, though, just a reminder that our next test is this coming Wednesday. It will cover the free fall stuff that we did for the past week and this vector stuff that we're going to do today, tomorrow, and on Monday. We'll review on Tuesday and take the test on Wednesday. All right, so let's just review one-dimensional stuff first. So we solve a 1D problem much like we would a displacement problem. For example, if Tristan runs 2 kilometers east and then 3 kilometers west, what is his displacement? So what we do is we just draw a vector, 2 kilometers to the east. Doesn't have to be perfectly to scale, but we do that, and then we can label it as 2. And then 3 kilometers would be a longer line and then moves to the west. So I'll do it slightly underneath it, and 3 would be about like that, and we can label that 3. And then our resultant vector, the overall displacement, is simply going to be a line from where we started to where we finished. That would be my displacement. That would be d, and d would be equal to, we'll say east is positive, so it would be 2 plus -3, and that would be equal to -1 kilometers, or 1 kilometer to the west. Okay. You might, when you're doing this, if you have a ruler with you, it might not be a bad idea to use a ruler to draw the arrows, but you don't have to do that. Just try to draw reasonably straight lines. All right. Now, a vector doesn't have to be displacement. It can be things like velocity and acceleration at all. So here's an example. Kate kayaks downstream with the river flow. So right here's our river, and the river flows this way, and she's moving this way. Right? If she's paddling at 3 meters per second and the river's flowing at 1, or 3 kilometers per hour and the river's flowing at 1 kilometer per hour, how fast is she going relative to the shore? Well, again, we can just draw. I'll do it this time without using the thing. So this would be the river going at 3, or Kate going at 3, and here's the river going at 1. And so the entire trip she's traveling 4 kilometers per hour. Right, so it's going to be 3 plus 1 equals 3 plus 1. Let's try that again. I don't know what happened. 3 plus 1 equals 4 kilometers per hour. Just 3 plus 1. Right? If she was paddling upstream, then again, the river was going this way, and then she would be going that way. So if she was paddling upstream, we'll say that downstream is positive, so she'd be -3 plus 1, or she'd be going -2 kilometers per hour, or 2 kilometers per hour upstream. Right? And if we drew the picture, it would be, again, 1 upstream, and then 3 that way, and then the overall result would be 2. Right, didn't draw that one too well. Let's try that one more time. Erase that. Right, I'm going to erase all of that for right now. So we go 1, 3, and then the final result would be 2. And it's -2 because it's moving upstream. All right, what if it was in 2 dimensions now? Okay, so in this particular case, Donovan kayaks across the river. He is paddling at 4 kilometers per hour, and the river's still flowing at 2. So again, here's our river. And our river is flowing at 1 kilometers per hour. This time they're trying to go across the river this way at 4. And so his velocity is going to be a combination of these two vectors, and we just have to add them together. Right? So basically, we would draw, in this case, we'd end up drawing a triangle. We would do 4 meters across this way, or 4 kilometers per hour across this way, and then 1 downstream, that one. And then what would our resultant vector look like? What would our result look like? We'd start sorry about that. The bell rang while I was trying to do this, and so I paused it. So at this point, what are we going to do? We have 4 to the north, 1 to the east, 4 across, 1 downstream. So our overall vector should start here. And it's going to end up here. Right now, this is not 5, is it? We can't add just 4 plus 1. But we know how to do this, right? We know how to find the hypotenuse of a right triangle. We just use Pythagorean's theorem. So if this was velocity, then v squared would be equal to 4 squared plus 1 squared. That would be 16 plus 1. V squared would be 17. So v would be equal to the square root of 17, which is 4.12 kilometers per hour. And the direction would be kind of northeast, which is all we really need to put in right now. Right? But the key on this is drawing it out. Draw that picture. All right, so let's look at a two-dimensional displacement. All right, so Tristan runs 2 kilometers east, then 3 kilometers south. What is this displacement? So 2 kilometers east would look something like that. That would be 2. And 3 will be a little bit longer. All right, notice my lines are nowhere near straight, but we get a general idea of what it looks like. And this would be my displacement. So d squared is equal to 2 squared plus 3 squared, or 4 plus 9. So d squared is equal to 13. So d is the square root of 13, or 3.61 kilometers. And the direction would be southeast. Okay, make sure you include that direction in there, or else we won't really have a good indication of which way they go. All right, so make sure that that you draw that picture every single time, and you should be in good shape. All right, let's look at one more, which is a little bit trickier. All right, this one's a little bit more complicated. We need to draw it out, but we also need to kind of start off to make our lives a little bit easier. Okay, so Susan runs 1 kilometer north, then half a kilometer east. She then turns south for 2 kilometers and 1.5 kilometers to the west. What's her total displacement? All right, now we could draw north, east, south, and west and try to do that, but we're not going to be able to do anything with that very easily. So I think the easiest way to do it is, you notice that two of them are north, two of the directions are north south, the other two directions are east west. So let's kind of put a little column here: north south, east west. All right, so north south, we want 1 kilometer north, so we'll say positive 1, but he also went 2 kilometers south, so minus 2. All right, so if we add those two together, we get minus 1, or 1 to the south. Right? If we do east-west, we have 0.5 east, we'll say east is positive, minus 1.5 west. So if we add those two together, we get negative 1, or 1 to the west. So now we can just draw it. We say one south, one west, and that would be minus 5 spin, right? Then d squared is going to equal to 1 squared plus 1 squared, which is basically 1 plus 1 is 2. So d is going to be the square root of 2, or 1.41 kilometers, and the direction would be southwest. Right, so when you have multiple directions, just look at everything that's northwest, north and south, and add them together. Look at everything that's east and west, and add them together, or subtract them if they're in the opposite direction, and then use those two at the end to make your triangle. All right, so now you've got several practice problems on there. Go ahead and try them, and I will tomorrow. I'll put up the key, and I will go through some examples of it. All right, so practices. I'll be online if you want to come on and on the Zoom call, and you can go ask questions. All right. Have a great rest of your day.